Hey everyone, Mr. Newman here. I wanted to record a quick video for you guys to talk about parent functions. This will be very short because honestly, all you have to do is name them, which like for example is absolute value, write the function, which is for example is f of x equals absolute value of x, and then I want you to identify the graph. So I really just care that you guys, when you see a graph, you can say which one it is and you know which function it is. Or if you're graphing it on your own, we're going to do transformations next. You can tell at a glance whether your transformation was correct because it should look like the parent function only stretched or shifted. Now, so I'm not even a fan of these practice problems. I just put them there because we always put practice problems there. Really, that's just kind of graphing, and you should just be able to look at it and go, oh, I think I know what this will look like. I know at least the shape it'll look like, and then. But we're not even going to practice that in class. We're going to move on to do something else tomorrow. But here's what I want you to do. Let's look through these. I got some things I want to highlight on here. So without further ado, first of all, notice that the constant function is just f of x equals a number. It could be 4, it could be -3, it could be 142.8. The linear function, in this case, this one, f of x equals x, is the identity function, y equals x. Identity meaning the same, so whatever you plug in, if you plug in 5, you get out 5. You plug in 10, you get out 10. That is the parent function of all lines. Over here, the book, and a lot of people call this the greatest integer function. I think that's kind of misleading. I much prefer a different notation and a different name. So the name of this function that I will use in class is floor function, but also be ready in case the book or some other problems use greatest integer. Here's the idea. Let me just show you. So that's the notation for floor function. I think even their notation is a little funny. So for example, floor of 3.7 is 3, floor of 2 is 2, and the floor of pi is 3. So each of those, you notice, you're basically rounding down to the nearest whole number. The ceiling function is the opposite of that. It looks like that. And for example, a ceiling of 3.7 is 4, the ceiling of 2 is 2, and the ceiling of pi is also 4. So what's happening here? You're basically rounding up to the next nearest integer. If you're already an integer, kind of, for example, at 2, then then the ceiling of 2 is 2. You don't round up any more than that. So they call it the greatest integer function. That's the floor function because it's the greatest integer that is less than or equal to your number. So that's greatest. I think of greatest as greater, larger, but it's misleading because most of the time greatest integer means less than the function, or less than the original value, or less than the input. So, all right, one other thing I want you to notice is, do you see how on this graph there are closed circles and open circles? Notice that, for example, the open circle I pointed to, that's at 4. So 4, 3 is not a point on the function. The floor of 4, or the greatest integer function of 4, is 4. So that's why it's a closed circle the next level up. All right, so a few other things. Concave up here is your quadratic that makes the shape of a parabola. And you have concave up is the expression goes up like a cup or down like a frown. Concave down looks like this. You see how the concave up is on top, the concave down is on the bottom. So it's basically whether you're smiling or frowning for concavity. Just another thing I want to point out to you guys. And then also here, this rational function, all the rest of them are parent functions. This rational function, though, is just, for some reason, they picked a very specific function to show you. Any rational function is just a polynomial divided by another polynomial. So, that lastly at the bottom here, I want you to notice some important things you need to memorize is that sine starts at 0. So sine of 0 is 0, whereas cosine starts at 1. So cosine of 0 is equal to 1. That's the main difference between sine and cosine when it comes to graphs. And another thing that I want to point out is that you've got these dotted lines. We call those asymptotes. Lots of the functions have asymptotes. For example, the exponential function, that has a horizontal asymptote at x equals 0. And logarithms have a vertical asymptote Sorry, I said x equals 0. At the x-axis, that's y equals 0. And this is at x equals 0. So the reciprocal function, this has two asymptotes, a vertical and a horizontal asymptote. And then even the rational function has, we call that a slant asymptote. So it can have vertical and horizontal, and it can also have slant asymptotes. All right, I told you guys this is going to be short. Thanks for watching.